Welcome back to the workbench. Do you ever need more than one power strip? In my case, for a tech table, for theatrical use, and you hate daisy chaining them, you burn one plug when you plug one power strip into another. So, we are going to learn how to make this into this. Stay tuned. I wanted to say that this project is for people with existing knowledge of working with electricity and tools, and people who have access to tools. What you will see in this video will include the tools that you will need. I will also put in the description pretty much everything I used, so that you have a parts list to do this project without continually running into challenges or missing tools or all of the hassles that I went through. So I'll include all that information. I hope you enjoy this project. Alright, it's safe to assume this is going to void the warranty. Another thing that you need to keep in mind is that your power strip has to have enough free open workspace inside to accommodate power jumpers. In this case, this is Neutrik PowerCON TRUE1. You could probably also do this with traditional Neutrik PowerCON. It'd be a little bit more of a pain in the butt, but either one would work. First thing we need to do is get rid of most of this cable. I leave about this much to work with, and then we can save this and use it for our daisy chain cables. Next thing we're going to do, pop open the Furman using these 4 screws. This, by the way, is the Furman FM. Oh, I'm not going to. Oh, there we go. The SS6B. I'm going to pop this open. Be right back. Now that we are inside the power strip, you can see that there's actually plenty of room over here for our PowerCON connector. It'll go in just like that. Easy peasy lemon squeezy. The next thing I'm going to do is just use a pair of nippers and get rid of this strain relief and the outer jacket of the cable. Alright, so we've got the jacket stripped. With the cable this short, I've had really good luck with just pulling out the inner conductors from that outer jacket instead of cutting or stripping that jacket all the way down. For the next chunk of work here, I'm going to tuck these cables back in the box, tape them off so they're out of my way, and the next step will be making the knockout holes for the connector. So I'll make these taped up and that prepped. So I have cut out the guide for this Neutrik connector. That's available on their website. You have to make sure that it prints out in the correct scale. Some printers will do scaling. The nice thing about this existing hole is that if we take a look and see where, how do I show you that? We can do a little flashlight. So you can see that this hole will actually get you really close to centered. One thing I learned from the first one I did is that cheating it up just a skosh is better, because this bottom strip here will end up pretty thin. So let me show you what I use to do these holes, which is a 29mm knockout punch. This is a sheet metal punch. One thing that I was caught a little off guard by, this Neutrik TRUE1 power connector is not a standard D size. Standard D size knockouts for XLRs, for everything that you normally expect, is a 24mm knockout. This one is 29. This outlet is a much bigger connector. If you're doing these individually, the power inlet is a standard D size knockout like all other XLRs for the most part. but this one is a larger knockout at 29 millimeters. What I've been doing is knocking out both sides at 29 millimeters. It works out really well. And there are, if you don't have one of these, I got this on eBay. Just search for 29 millimeter knockout punch. They're really not that expensive at all. I mean, I shouldn't say that. It's like $30. You can also, the first one of these I did, just use a step drill, making sure that you stop on time and that you are very conscious of the fact that as you drill in, you have to be very protective of the wires inside. So let me get this knockout punch all set up and ready to go, and I'll be right back. Alright, so I have centered this knockout punch in the middle of the existing cable hole, and the next step is just to take an Allen wrench and tighten it until we make our knockout. For this particular punch, it's an 8 millimeter. So, with sheet metal this thickness, there's actually not much effort needed at all. I'm going to show this process for the first hole, just so that you get a sense of why I decided to purchase the sheet metal punch after trying the step drill. And again, that step drill did work just fine, but it definitely got a little shady near the bottom. So once you get your hole, you end up with this beautiful knockout. And that's all you have to do. So I'm going to use my Neutrik template to knock the center point of the next hole and get that drilled out and ready for the other knockout. Now that we've got our new hole marked, we can go ahead and drill that out. I always start with a small hole just to make sure I stay on center. And then we can bump up to the next size drill bit, which will accommodate the screw shaft of the sheet metal punch. And with that hole drilled out, we've got the sheet metal punch lined up to knock out the next hole. Alright, and the cutting mat has disappeared to accommodate our vise. I have a second printout. I actually recommend having both of these templates. I just printed it twice. Once for marking the center, and the other one for marking the full size of the knockout, which I will just line up like so and draw the lines. This does not have to be exact. We're just cutting through it. So now that that's marked, I will use the, well, I'll show you. I have a Dremel with a cutoff wheel, and I just follow along these lines here. So instead of getting a bunch of sparks and sheet metal dust into the camera, I will be right back. And we're back. That didn't take long at all. 2 real short cuts with the cutoff wheel, and we've got ourselves a correctly sized knockout for this little guy. You can see that there is a little glob of hot snot here for this LED. There is enough room to accommodate the panel jack, but you kind of have to slide it in from the top, and then it will once we get this secured, it will push against that little LED a tiny little bit. Nothing to be concerned about, in my opinion. So our next steps here are going to be prepping the wires to go on the panel jack. I'll be right back. Alright, so I untape the cables, strip them, and put some crimp connectors on there to go along with the tabs for these. Then you feed your wires through. Oh, there's also heat shrink on there for bonus style points. So you can feed all the wires through, plug them into the appropriate tab. I don't know if you can, well, you can see, but there is load, neutral, and earth. And you get those wired up and heat shrunk. Alright, so made those connections, shrunk the heat shrink, and dressed the wires. These all lay in nicely along the receptacles here. Double check and make sure that you don't have any leftover pieces of metal scrap from cutting, any shorts, anything that looks shady in here. And the final step is to start drilling some holes and putting in rivets. Rivets, I found, are the easiest since it's impossible to get under the bottom. So I'm going to drill a handful of holes here. And 4 rivets later, and we're done. So the last thing we have to do here is put the bottom lid back on, and then we'll move on to making those Neutrik jumper cables. After thinking about it a little bit more, I'm going to end this video here with this as a completed project. I'm going to create a separate video on making the actual PowerCON TRUE1 cables, because it's a whole nother process, and also people who want that information probably don't want to see all this. So I hope this helped. If you have any questions, let me know down in the comments. And once you have a handful of these, you've got a pretty great setup. Some of you might wonder, like, why am I doing this? Why would I go through the trouble and expense of making this instead of just using power strips? The main answer to that is, one, this is expandable. It's very convenient. When we are in tech rehearsals or previews at the theater that I work in, we have very fast changeovers from a tech rehearsal into a preview. It's great to be able to keep all these tools easily accessible, quickly set up and struck. And secondarily, my sound designers that come into the theater, they are plugging in their entire livelihood to the tech table. It is their computers, their hard drives, their archives, everything they need to be a sound designer is getting plugged into the tech table. So the least I can do as the sound supervisor is to give them a nice power strip, some power protection, surge protection, so that they know when they're plugging in their entire career, there's a little bit of protection. Of course I can get a cheap power strip. Of course we can do that, but it ends up making the table very disorganized, and at the end of the day, the added expense of putting these together is worth it for me. Thanks, guys. Oh yeah.